Hello dear friends, in this video I will explain several sheet metal functions in SolidWorks. Click on part, select the front plane and draw a small rectangle here. Let's make it 100 millimeters long and 50 millimeters wide. Now we select sheet metal and use the base flange command to extrude it by 1 millimeter. Okay. After that, we create an edge flange. Select the edge. Excellent. Do the same on the other side, 50 millimeters. 50 millimeters. Set the type so that the material is inside and the radius to 1 millimeter. Okay. After that, repeat the same command for 49 millimeters, that's right. Also with a radius of 1 millimeter. Okay. Next, we draw a sketch on this surface and draw a line here. And we set the distance to 20 millimeters. I want to demonstrate how one plate will overlap the other for convenient welding. $20 millimeters. Next, exit the sketch. Select the lock command, remove it from this side and select the plane. If we choose this one, nothing will work out. Select from this side. You can see that a point has appeared indicating from which side the bend will occur. This way it will make the bend from this side. This way it makes it from this side. We need it to make the bend from this side. Here, set it to 1 millimeter. A direction appear. Set it to 1.5 millimeters. Approximately 1.5 millimeters in length. Measured precisely at an angle of 60 degrees. Yes, the type is correct. Okay, now we've made this little bend. Let's make a sketch here. And with a small square, we draw up to this point. Now, approximately, select one point and another point and make them coincident. After that, go to sheet metal again and select the base flange command. And check the emerge result box. Okay. With this kind of complex joint, you can easily weld the two ends of the plate together. If we hadn't made this joint, it would be very difficult to weld because the metal is so thin and it would burn through. This is the first feature I wanted to demonstrate. Let's close our document. Save it if you want. I'm not saving it because I already have a version of this document. Now I'll show you the function for creating a fan grill in SolidWorks. Sheet metal, sketch, flat from the front. And here, first we draw a square. Exactly 100 by 100, measuring precisely 100. Great. Now go to sheet metal and extrude it by 1 millimeter. Create a sketch on this plane. Press Ctrl 8 to set our view perpendicular to the screen and draw a circle from the center. Another one, also from the center. And then one more, and 156. And the last one. We create this circle with a diameter of 80 millimeters. Here, we set the distance between the circles to 10 millimeters. And so between each gap, between the circles. Now take a line and draw it from one top point of the circle to the other. Simply double click to disable the line, ending the line. There we've created the lines. At this point in our workflow, the next step involves navigating to the sheet metal section within the software interface. Sheet metal in this context refers to a specialized module or workspace designed specifically for creating, editing, and managing parts that are intended to be manufactured from sheet metal materials. To access this area, look for the tab or menu labeled Sheet Metal in the main toolbar or navigation pane of the application. Once you have located the Sheet Metal section, click on it to enter the dedicated workspace. Here you will find a variety of functions and commands that are essential for working with sheet metal components. The next step is to select a specific function you need to use. This could include operations such as creating a base flange, adding bends, inserting cutouts, or applying forming tools. Each function is designed to perform a particular task that is commonly required in sheet metal fabrication. For example, the base flange function allows you to define the initial shape and thickness of your sheet metal part, while the bend function enables you to add bends at precise angles and locations. To select a function, review the available options in the sheet metal toolbar or command panel. Hover over each icon or menu item to see a brief description of its purpose. Once you have identified the function that matches your design intent, click on it to activate the tool. The software may then prompt you to specify parameters such as dimensions, angles, or material properties, depending on the function you have chosen. Carefully enter the required information, making sure to follow any best practices or guidelines provided by the software documentation or your organization's standards. By following these steps, you ensure that your sheet metal part is created accurately and efficiently, taking full advantage of the specialized tools available in the sheet metal module. This detailed approach not only streamlines the design process but also helps to prevent errors and ensures that the final part can be manufactured according to the desired specifications. In summary, the process involves navigating to the sheet metal section of the software, familiarizing yourself with the available functions, and selecting the appropriate tool to carry out the next step in your design. This methodical approach is essential for achieving high-quality results in sheet metal design and fabrication. Select this edge. 2 points have appeared. They show us where the count of all our lower model parameters starts and ends. And now select this face. Set 3 millimeters here and 3 millimeters here as well. 5 instances. This is the number of instances we have. There is also spacing clank. This is the distance between our teeth. If we adjust it, the number of our teeth will either increase or decrease. I select equal spacing, where you can enter the number of instances as a value. You can also extrude our teeth and, for example, connect 2 plates. And if you want some parts to protrude, you can simply specify the length and they will extend beyond the edge of our second plate. We edit our tab and slot, and I will set auto surface for the surface. Next, here you can specify the types of our cutouts. I will select this type and it will fit into the plate like this, but others of course will fit differently. Here you can also specify new groups. For example, if you have a corner here as well, right here, you can specify it here just like in the previous window and then set different parameters for it. Click OK. Now we can see that cutouts have appeared in one of the plates, and in the other, on the contrary, elements have been extruded. And after that, it's easy to weld everything together here. This is just a small part of the features I wanted to talk about today. This was Alexei Aktifeev. Subscribe to our channel and give this video a like. Bye bye everyone.